Great to be here. Quick intro about me. I work at Discover Financial Services, been there for 9 years now. I'm the director of data science research. We deal with a lot of burning issues in ML, specifically on the algorithmic side. And today I'm going to speak about explainability and bias in ML models as the focus, right? So before we get into explainability and bias, I just wanted to give everyone an overview of how we use models, right, at Discover. Discover uses behavioral modeling for pretty much everything we do, whether it's marketing to our customers, whether it's authentication, commonly known as fraud detection, underwriting, right? So Discover is in the business of selling financial products. We need to make sure credit risk is managed. We do customer servicing, which means a lot of the stuff you hear about, NLP and Gen AI is very relevant there as well. There is line management, which is once you get customers on our book, how do we manage them, right? And then there is collections. Not everyone always, pays back their dues on time. How do we encourage people and help our customers who fall into hardship repay our money back, right? So, jumping into something more technical, Discover has been using machine learning for the aforementioned models for a while now. I think starting in 2017, roughly, we built our first machine learning model, which replaced prior logistic regression-based models. Today, most of our models are based on XGBoost, right? These are tree-based models, ensembles, which we use. The question then is, how do we explain these models? Before getting into why explainability is important, there is some context I need to provide, which is in financial services, everything we do has to be explainable. We impact a lot of customers, right? And so we need to explain to them, especially when we take adverse credit decisions, for example, why we made said decisions. And it has to be pretty spot on. You can't be wishy-washy about things. You need to tell the customer exactly why you took a certain decision. That's why explainability is important. And in the context of explainability, there are a variety of approaches out there, but broadly, I characterize them into two types of approaches, right? One is what I refer to as post hoc explainability. And then there's one which I would refer to as self-interpretability or intrinsic interpretability. Discover has original solutions in both of these areas, which I will shortly talk about. So my team came up with this approach, right, to address both types of explainability. So firstly, what's post hoc, right? Post hoc refers to the fact that it is something which explains the model after the fact, right? And hence post hoc. Typically, post hoc methods are also model agnostic, which means you don't need to tell me, hey, I built a XGBoost model, a random forest model, a neural network, some other deep learning model. You just tell me what's the input, what's the output, and I sort of tell you what's the input-output relationship. The other branch of models which help directly with explainability is what you would call a self-interpretable approach. So in years past, when people used logistic regression, you had coefficients, right? You had an equation, you had coefficients, and coefficients sort of help explain the model in some sense. With machine learning models, that is no longer the case, at least not trivially, right? So there are these class of models which are self-interpretable, and we came up with an approach recently which sort of marries the post hoc and self-interpretable approaches, which is specific to a model, CatBoost, for those of you who care about it. Actually, the guy who developed this is in the audience somewhere. I'm not able to see him, but if you want to speak to him at the end, Hush IR, and you're really into tech speak, talk to him. All right, so why, there's another concept which we sort of innovated on, right? So context, we have a bunch of inputs which we use for our models, right? And many of these inputs are highly correlated, and this presents a problem for explainability. Now, one of the concepts which my team came up with was a concept of grouping similarly sounding variables, right? I'm being very vague deliberately here. And I don't want to use the word correlation, but you could think of it as correlated variables. We would want to have a way of grouping these variables and then explaining how these variables impact the outcomes of these models. And so this is just an illustration sort of saying, hey, if we had a bunch of variables which explain a person's credit risk, you want to sort of see not the minutest sort of base variables which contribute to a decision, but maybe you want to aggregate similarly related variables into something which is more meaningful. So an example here, for example, is credit utilization, right? So we use credit utilization, which for those of you who are not familiar with that terminology, credit utilization would represent, for example, how much of your credit card you're using every month, right? As a rough way of predicting things. You have this in the last 6 months, 9 months, 12 months. Each of these could be an input to your model. One of our suggestions was to group this together to see what are the most impactful attributes. There are a lot of reasons why we actually want to do it from an accuracy perspective. Unfortunately, in a lightning talk, I would love to get into those aspects. I can't. Okay, so there was the concept of grouping, and then I promised to get to something on post-hoc interpretability. The state of the art today, as most people approach post-hoc interpretations, and this is true not just of tabular models, but also, the broad class of deep learning models, is using some form of Shapley values. There is a big problem, and if there's nothing else you take away from this talk, there is a big problem using open source Shapley value packages, right? If any of you are doing it anywhere, or if you heard a company tell you they want to give you something on explainability, please ask them what kind of Shapley values they use, and typically nobody will have an answer. The details are important. As a result, we combine the concept of grouping with a version of Shapley values where you can sort of look at the individual contributions of members of features in a group, and the terminology or the game value you want to use is something we refer to as the Owen value, which incidentally has existed for the last 50 years. But this is something you really want to use for more accurate explanations of models, right? The other thing which we talked about was self-interpretability. And here we want to focus on using structures within models which limit, in some sense, how much flexibility a model has, but at the same time using this limited flexibility to in turn explain the model. So one example of that I referred to was cat boost. And the reason why cat boost is more easily self-interpretable than something like an XGBoost, which is more popular, and as I mentioned, is the bread and butter model we use at Discover, is because cat boost has symmetric trees. So notice in the picture out there that cat boost always splits on the same variable in a symmetric manner, and the trees grow in a symmetric fashion. This is very important to get something like the explainable models from the days of logistic regression, right? So in general, constraints are not a bad thing on our models. Constraints can help us make models more explainable, right? That's the high level message I want to pass on. Okay, so I'm going to stop about explainability, and I'm going to talk about another topic which is very popularly discussed, which is AI is biased, right? In particular, people talk about how algorithmic bias leads to all sorts of problems in society and so on. Right? Especially if you hear a politician, you would believe you use AI, you're going to end up harming someone in some way. Okay, so in financial services, this is a big deal because there are regulations which deal explicitly with bias, and institutions can suffer great reputational harm if they do not account for bias in their models. And this was true even before the advent of ML and AI, right? We came up with an approach to sort of quantify, explain, and then mitigate this bias. And I will very briefly walk you through what we did. And then in the end, I will sort of refer to some academic papers we have out in the public domain, which anyone who's interested in the technical details, welcome to refer to, and then reach out to me if they have any questions about it. Now, 3 steps, right, in general, and this applies to any kind of bias monitoring tool anyone wants to build ever. You need a metric, right? You first need a fairness metric. And believe it or not, it's actually difficult to come up with a metric for fairness. There are many metrics proposed out there, but often these metrics are almost, you can't satisfy all fairness metrics at once, right? There's a sort of impossibility theorem for those who like math speak, that you can't meet all these fairness conditions simultaneously. So you got to pick a fairness metric. And the fairness metric we picked was somewhat intuitive for the applications we have. It may not be true for all applications. Next, you want to explain the sources of this bias. Why? Because you don't want to just tell someone, hey, my model is biased. You want to then say, hey, what caused that bias, right? I mean, all bias flows from data, which has a historical context. So that's not what I'm referring to. I'm referring to the sources of bias specific to the inputs of the model, right? And then there is a third step, which ideally we want to do, which is how do we mitigate this bias? How am I doing on time here? Have 30 seconds? Okay, good. So I'm going to, in 30 seconds, complete my talk because I have only 3 more slides. Metric for fairness, a Wasserstein distance. This measures the entire distribution of scores and how there is bias between a protected and a non-protected class. That's 10 seconds. Sources of bias, use Owen values, which I already talked about. And 3, to pick a less discriminatory alternative for a model, which is technical speak for saying how do I mitigate bias, generate a set of alternative models, and cleverly massage your distribution of inputs in a way which gets you minimal bias without sacrificing a lot of model performance. And with that, thank you for the opportunity to talk. Thanks, DTE and AI Meetup. I hope I got that right. And happy to see all of you here today. Happy to answer questions right now.
All right. Well, let me get this thing in my pocket. So hello, I'm Shannon Schultz. I have been at Discover for 16 years now, so quite a long tenure. I've held many different roles throughout our technology space. So I came in as an engineer. I did a lot of architecture for a while, and then I'm kind of focused on both now in my role. And I am a director leading our machine learning platform at Discover. And I just recently moved into our data science space. So working closely with these guys and delivering technology for them. I'm excited to do our technology talk today. So I know a lot of you are data scientists, but we wanted to tell you a little bit more about kind of what we do to enable you guys and everything you're building into a production environment. So I thought I'd start with what is a platform, right? So I've heard many definitions of this, especially from people in technology, but also out of technology, right? So sometimes people refer to it as a specific tool. Sometimes people refer to it as, just a collection of tools. But I thought I'd ground us in my definition, or the definition that I relate to most. So for me, a platform is a collection of capabilities and tools enabled by products that are foundational in supporting user and application needs to accelerate time to market, right? So we're really like building something that kind of bridges everything together. So in the technology space, we call it integration. So it could be something that we build, it could be something that we buy. I actually put this illustration up here. This is, all the different tools that exist in the marketplace. And it can be overwhelming, right? And some of them work well and some of them don't work well. So it's important to understand like kind of what you want out of your platform. And I kind of get into that in the next slide. So as you build a platform, you want to set some guiding principles. And I definitely, started with putting together this kind of view of where a platform sits. Going back to that definition, some people always think of platform as infrastructure. but we actually sit on top of infrastructure, and then we enable applications and eventually like consumers of those applications. So the example I give a lot is all of us have phones, right? So the base of the phone is the infrastructure. The platform could be iOS or it could be Android, depending on your drink of choice. And then, you have apps that sit on it, and then you're the user of those apps. So that's kind of how easy example of how to do that. But when you're thinking through your platform, you definitely need to enable that through a set of principles. So we always start with mindset. So there's always a bias to evolve our assets, right? This is why you're like building something, you're modernizing it. And I know Jonathan referred to something that we often use in tech is people, process, and technology, right? Because all these things are important in your equation when you're building something. You definitely need to define what your platform is and what your platform is not. Because oftentimes if you go to the what your platform is not, then you're trying to manage a bunch of stuff that you weren't expecting or wasn't part of, your mission and vision of your platform. And lastly, you need to know your personas, right? You need to know, like, I'm going to have people who do data scientist work. I might have some analysts. I might have, in our world, we have decision scientists that sit on our platform as well. So it's really good to understand them, how they work, what kind of tools they need to do their jobs so that you can enable that into your vision of building. And then just some common themes that we look at is we definitely want to automate as much as possible. And my team calls it thoughtful automation, right? Because not everything can be automated. And also as you're automating, you don't want to just lift and shift what wasn't working before, right? So you don't want to like put steps in your process that you don't need. You definitely want to be able to scale. You want to make it simple. I know we always talk about security in the financial space, right? We got to like secure everything that we're incorporating, including data, including some of the models, because all of that, is something that we want to keep tight from the bad guys. We want to make sure our platforms are reliable. I use this word abstraction, and I'm going to focus on that for a second, but it's really about how do I make my users not think about the mechanics below, right? So I want to make it as easy for you as possible. So anytime I need to add a new tool, for example, or abstract a new tool, like I don't change the interface that the user is using. User experience is definitely a key part of your platform. Being able to have repeatability, right? So we call them patterns in the architecture space. So you might think of a pattern as a batch model or a real-time model, right? Like each of those is a different pattern and requires like different capabilities in the platform. We want to get to as much self-service as possible. And then last, we want to be able to enable emerging concepts. So people like Arjun, when they do their R&D, can easily put new functionality within our platform. Just want to talk a little bit about some of the common challenges that we have at Discover, and I'm sure they have them across the industry as well. But with our machine learning implementation, it's a complex process. So we involve lots of different teams in order to do that. We were originally missing a centralized way of practice. And I should have started with, this is before we had a platform. So this is kind of like why we came up with having a platform. So we were missing a centralized way to do everything. Every team was kind of building on their own and kind of putting things into production on their own. We were doing a lot of recoding. So a lot of the features, especially that were being built by our data scientists in Python at the time, we were having to recode because our capability only supported Java, as an example. Data is always our challenge, right? So how do we synchronize data across all our different platforms, whether they're being used for development, training, or into production? And then just a lot of stuff passed through spreadsheets and PowerPoints and just getting lost in translation. And those always lead to, lengthy builds, lengthy times. I think at one point we were at like a year almost to deploy a model in production. So we definitely wanted to fix that. This next slide, I won't take too much time on, but it kind of, lays out what our platform is kind of achieving. So it's really trying to bridge everything that you would do as a data scientist. And again, like back to that integration world and like putting a bunch of tools and capabilities together so that everything is usable, right? So it starts with a UI or user interface that people can go into and, do their job. And then it moves from, everything flowing from data, being able to create features, being able to develop your model. And then we get into the production space of putting that model into production and like how we do that and govern it as well. So I could talk about a platform all day, but since we're doing a lightning talk, I decided to pick one area of focus. So I did decide to pick our ML ops space. And just give like an example scenario of something that we built. So this was something that started back in 2020, really coming up with a reusable framework that we could put our models more easily into production and make our time to market faster. So we built this mostly on a lot of technology that we already had, because typically when you're starting, you want to do that before you try and go look what is out in the marketplace. So just some common themes. We definitely wanted to have something that was reusable. So we did that through what we call an image. So this is us packaging your Python version, your XGBoost version, like anything that you are going to use, we kind of make that into a deployable unit. We want to make sure that everything is configurable. Right. So again, back to the framework and being able to like reuse, just everything is just different parameters that you're going to set that will use the same framework. And then definitely back to the security model, we wanted to make sure everything goes through, the authorization and auditability that you need. We also, our Shanghai team actually built out a set of common reusable libraries that our data scientists can use. And we use that and incorporated that into our framework as well. We definitely wanted to make things simpler. So we reduced a lot of steps that were part of the process and a lot of handoffs that were happening, right? So I talked a lot about recoding a little bit ago. So in the old world, we were doing a lot of, we would get the data in Python, we'd actually like reconvert all that into Java. Sometimes we get it in SAS and we'd still reconvert it into Java, right? So if you could imagine, like, that takes time. There's often, not making mistakes because you don't know what the other person did in the previous language. So we wanted to make that as simple as possible. Automation, so wanted to make sure, like, as we like move from left to right, putting it in production, it was automated as possible. And then making sure it's scalable. So making sure as you pick out your different infrastructure, that it could scale the workload. So if you have a lot of data, for example, you might not run on the same machine that if you're just running, a small model. So definitely wanted to create that scalability. Then my last slide really just covers our evolution of this. So as I mentioned, we started in 2020. So this was around the time I started kind of working on the space. And when I came in, I think the first goal was being able to just put a Python model into production, right? So something which sounds very easy, but we hadn't done it. So that's kind of how we started. And that's kind of how we decided to figure out what our roadmap and what our journey would be. As we got into 2021, we used that and we made the framework on the previous page and able to like continue to develop that, test it, try and put in more and more models. So I think we did about 10 plus models on the new framework in the first year. And I should mention they were batch models. Because as I get to 2022, we then took the same framework and implemented our first online real-time model. So we were able to actually not have to tweak a lot of what we did. But we were able to actually like take that and make it so that it was more API driven and microservice driven than just, running the same job over and over again. Additionally, in this year, this was when we hit our first model of big scale. So we had about a 60 million row data set that definitely caused us a little bit of problems. Back to that, knowing what your infrastructure component is. So the nice thing about our framework was we just had to implement a new methodology to kind of figure out like, okay, how big is my data size? And how do I actually like scale out my infrastructure? So that was something that we added. And then we're in this year. So definitely this year we've been doing a lot more of like what we call hardening our environment, right? So again, making it more scalable, adding more reliability, and being able to just integrate with other enterprise platforms. We also just recently started doing more user enablement on our platform. So working with our data scientists to kind of put them in the streamline of events. So again, we're trying to get rid of some of this handoff that we were doing previously. So that helped us scale our workload and put our models in even faster. So that's kind of where we are today. And I just like to always just say that our delivery is always an iterative process. We're always continuously learning, and it's important to be able to shift and adapt as we move along. So just thought I'd end there. And yeah, any questions?
Hello, I'm Ben Zhang. I lead a modeling team in Discover, supporting machine learning in fraud, AML, and collection. So the contents that you see today is a little bit less connected with my topic, which is you're coming in, look for something fraud detection models or AML. You will be disappointed because the slides that I had we have some secret sausage and some numbers, so it was pulled out at the last moment. So here you see this is the lesser intense of today's talk. Okay, so we're going to talk about a few misconceptions or misunderstandings in terms of machine learning. The first one is machine learning is new, especially like last year or this year, we have this chat GDP and large language models. So we're thinking, okay, this machine learning is probably past 2 years, 3 years, or past decades, but I think that's not true. I'm going to use the example of FICO score. Everybody has a FICO score, right? That's it's the probability to measure the consumer's probability of not repaying their loans or their debt. So that's in my mind, that's the earliest, the pioneering product, that the first successful user case of machine learning. Actually, for those of us who in this field of financial area that we're working on model, we own a great deal to ASIC, that they pioneer this thing, basically open up the whole field. So we all benefit that. So I want to get that out. So that is they use logistic regression models or linear models. Maybe they're also advancing, but these are the very first usage of machine learning. So that's the misconception number one. Number two is machine learning models are statistical models. The answer is no. In my personal view, the machine learning models evolves educated guess. That's it, educated guess. So we made that educated guess by using all these forms of functions. It could be linear functions, nonlinear functions, a decision tree, a random trees, a forest of trees, right? Regardless, these are the tools that you use to make an educated guess on something that's objective. You make an educated guess. And then what? And if we're off mark, and then you got this is called loss function. So I don't know if, I mean, probably most of you are very familiar with this loss function. So what is that? That is the, I would say, the penalty of us being off mark. So you see this, you have all these predictions and you're off, right? You have an actual number, I have a predicted number. Then the distance between these two are the loss function. You have different forms of loss function. So machine learning is to constantly learning, evolving, measuring to fit, to minimize the loss function. That's it. Regardless of the statistical models in the past, right? Logistic regressions, nonlinear models to the GBM models, boosting models, it doesn't matter. It's the educated guess, billions of times in a second, and fine-tuning all your predictions and minimize that loss function, minimize the impact, the actual, between actual and predicted. So that is the second myth here. Anybody knows the logistic regression, right? Everybody knows. So in that case, I kind of have two words, keywords in this second myth is the mathematical convenience. So in logistic regression, you make that assumption, the error term is Weibull distribution, right? Why? Because I can share that with you. It's Weibull distribution is just very normal-like, and yet they have a closed form solution. So that's why it got picked up. It's so popular, it's so convenient, so easy to use. Because of what? Mathematical convenience. So that is the same logic that apply to today's large language model, like boosting models. Every forms of these algorithms shoot for that mathematical convenience to minimize the loss function. So that's the misconception number two. Number three is these machine learning models update themselves automatically. So see here, this is called update. It's not learning. So in my mind, the machine learning, today's machine, I mean, I'm not sure about tomorrow, what next month, what next year, but today, all these machine learning models are not learning by itself automatically, right? We can make it as Arjun said, we are as financial institutions, we need to monitor everything, right? Input, output, explainability, everything. But just go beyond the financial industry, these models are not learning by itself. I'm happy that is the case, because I don't know if any of you have been nervous after the ChatGPT, right? Oh my God, this is coming out and it's taking over. So after I used it for a while, I'm kind of calmed down a little bit and think, okay. So the machine learning, or today's machine learning, does not have that ability to be inferencing. That inferencing, the capability, the logic, it could not have that. So that means that machine learning does not have the capability to learn something that they haven't seen. You see all this from Google, from Facebook, from these big guys, right? They learn things like tremendous data, tremendous power, computation power, but they learn things that has been existing, has been in there in the past. For the inferencing capability, I don't see that. So I don't see, at least now, these things. I don't buy that argument. So that's the part that I want to make sure that I convey that. And of course, the other thing that I want to mention is the again, coming back to this ChatGPT, so is there a way to replace humans? So you see that the GPT, these large language models, that the lack of capability of inferencing, right, put more premium on the human ingenuity. Again, I think, if you ask me, what is the, is there a way that a stage that with machine would think as humans? I think here's my take, right? As a human being, I don't know if you Anybody all knows the game theory? John Nash equilibrium, right? That beautiful mind, that movie, that you see everybody maximize their utility function. You have your function, I have mine. I have 100, you have 200, right? You have different weight. So you always maximize your utility given the fact that everybody else maximizing theirs. So that is the foundation of economics, or no, not like human behavior. That's I truly believe that. So in that way, the machine does not have a smell, does not have a vision, does not have a sound. They don't hear, right? They don't interact with people. So that is before they have that capability, the human ingenuity or the human's power of inferencing from somebody that is completely from the history to something that completely unknown. There's nothing doesn't exist, would be still at premium. So that's I hope that's give you some confidence or comparability. That's my take. So these are the three misconceptions. So these, again, I think Arjun touched based on all of these. So this is a progress that we made in the area of fraud detection, that from regression to GBM to a boosting-based approach, and then to deep learning with graphic data. So that's how we do it, step by step. So I'm not going to spend too much time on this slide. I would be open up to some questions. Q&A, any questions?
Well, thank you very much. And I'm incredibly honored to follow our amazing technical experts here. Wonderful job, you guys. And I get to close this out this evening with one final talk. Hopefully I can leave you with a little bit of inspiration when it comes to innovation. I have to believe in a room like this, we all have some pretty big ideas. We want to take the next step. We want to see the next thing for our business. And so hopefully this is a little bit of some practical tips on how to do that. I am within our technology organization, and we really believe strongly in innovation. We have a number of ways that we drive innovation throughout the company. And so this is one of the spaces that I get to speak to as I do work really across all of Discover. One of the themes that you will certainly see here, I want to tell 4 very quick stories to illustrate these points, and they're all going to center around us, around you. We are dependent on a lot of people, but thankfully, we also can bring quite a bit when it comes to innovation. So, and it's even possible in financial services. The first one is ideate. Ideation can happen in a lot of different ways. I think one of the best ways it happens is when you're building your own craft, you're doing your job. And as you're doing your job, you're always thinking of ways to improve and do things better and different. At Discover, we have something that we call golden paths. They're the way that you can step by step do something that's going to work at Discover. I don't know how many of you have moved to a different company, thought you knew the technology, had done certain processes, and you get there and you're like, this does not work the way that it worked at my last company. And that can be true in a lot of times. And so we've created these paths to say, this is going to work at Discover. This is the way that we support it. This is the way that we use these tools, hopefully to give you a head start. So in doing that, one of our teams in our payments organization was trying to figure out how to do some very challenging things in vulnerability management. It's a really important part of doing development, and it can be very complicated and challenging. And they found the path through the tools at Discover to get that job done. And it took a little bit of time, but they wanted to share that. And so what they did was they partnered with our Golden Path team, and they made a path that others could follow. So it may not sound like mind-blowing innovation, but it was incredible turnkey for a number of teams to take those learnings, see them codified, and not have to stumble through the same things that the payments organization did. And that was just a function of them doing their job and finding a way to do it better. The second thing that I would say is to advocate. And one of the ways you can advocate is find the forum that you can advocate in. So there's got to be people within your company that are like-minded. They want to share some of those same ideas. Sometimes it's a small group. Sometimes there's a large forum that exists. And sometimes you have to create the forum. So one of the things we did over the last couple of years is we launched what we call internally DevWorks. And it's the forum that we utilize to promote developer experience within and across the company. And it came from a number of developers saying, like, I want to do this better. I want to do this differently. I have an idea. I'm hitting a roadblock. And so we got that momentum and we got those ideas and we created a forum for it. And we've seen incredible success. You know, a lot of times prioritization is built off a lot of different things, but sometimes it's really aided if you know where to go with your idea. And if you can bring it to a forum like DevWorks and you can get the sponsorship of some of the leaders and the voices that are there, you can get something done. And we've seen that happen again and again with a lot of success. So an encouragement to, as you're advocating for the ideas that you have, find that place that it's going to sit really well that can add you and your friends behind the idea. You might be catching a theme by now. Maybe I've listened to too many sermons. I don't know, but they all end in the same sound. So you can guess what the last one is. I challenge you. The third one is to activate. Sometimes this is a good, sometimes this is a bad, but I will just say that, you know, some of the best leaders that I've seen have a common trait, and that's when they see something that's really important, that adds a lot of value, they take it and they run with it. And I think that's true for any seat that you're in. If you have a great idea, one of the best tools that you have, the superpower that you have, is your time, your abilities, your connections. So taking that first step to take action on your idea can go a really long way. It's not 100% complete, so I can't share all the details, but my team is a great example of this frequently. And something that's happening almost completed right now is, you know, they were looking around the enterprise. They saw a technology and a tool that would be really game changing for us. And there wasn't really a blueprint. There wasn't a golden path necessarily for how to bring it in, get it done. And they said, well, you know, I could probably throw this over the fence to another team who's done something similar, or we could just figure it out. And they worked together, started to bring in some other people, created that forum, and really took the initiative to push forward and to make it happen. And so, yes, we need support from other people, but oftentimes taking the first step, using the time that you can create and carve out to do the thing that you're passionate about, is incredibly powerful when it comes to making change and driving innovation. If you didn't guess, I'd be really impressed if you did. The last one, great word, emanate. We talk about this sometimes internally. You know, I work with a lot of really amazing, humble people, but it's important to share the things that you do. Each of you have expertise in your own ways, and it's okay to, you know, give credit to the people that are behind you and around you that have been doing the work, but to also take some of the credit. I mean, you have incredible ideas, you do meaningful things, and, you know, find a way to share it. Next time you go to a conference, share the thing that you did, find a way to speak. When you've come up with a solution like that first team did, share it with others, make it bigger. That really gives a platform for the cool thing that you did, and it helps others adopt it and make it even bigger than you thought. A great example of this, again, your QR codes will work. Can't see his picture in the middle there, but this is Jeff Godwin. He is an amazing individual who works within our area. He loves technology. He loves architecture. He took it on himself to just do some educational videos within Discover. Really cool, really funny. It's called A Moment of Your Time. And recently that people sort of caught on to that, and it turned into an external thing. So that's actually a YouTube link that anybody can see. And he's got a series of videos. They're amazing. He's a fantastic, again, very humble guy. But it's a great way for him to show the things that he's done, the things that he's innovated on, the things that he's passionate about, and bring it to the rest of us. So again, hopefully just 4 simple steps that I can leave you with. Think about these as you're doing your daily work. You're the main power behind your innovation, and you can do a lot of things. So hopefully you take one of these things and take it into your next, the rest of your day. With that, I want to thank everybody for listening to these, and I'm going to open it up for, oh, sorry, I have one more slide. There are more ways to get in touch with us and to hang out with us. Again, if you needed those QR codes to visit some of the things that we have on the web, and then that Windy City Tech Connect is up as well.